Welcome to our final lesson in Unit 1B. This is lesson 3.6, and we'll be defining variables in terms of one another, modeling distance, rate, and time problems. If you ask former algebra students, the distance, rate, and time problems are those problems that tend to be a little bit more challenging, and those are the problems that usually a lot of algebra jokes are made from. So two things that are really important here are understanding the term consecutive integers. And so consecutive integers means that they are numbers that, integers, that are separated by 1. So 2 and 3, those are consecutive integers. They're back to back. And the other is that an object in uniform motion is going to follow that distance equals rate times time. So in our first example, we are dealing with consecutive integers. So we have the sum of 3 consecutive integers is 72. And so you want to think about, we could use x, y, and z, x being the first integer, y being the second integer, and z being the third integer. But I want you to think about something. That first integer is x. If we let that first integer be x, okay, let me ask you this. If that first integer were the number 72, tell me what the next integer would be. It would be 73. And then the next one would be 74. Because they are only separated by 1, we can write them in terms of each other. So if x is that first number, that represents 70. Imagine it represented 72. We could take that 72 and add 1 to it, and that would give us 73, which would represent our second integer, okay? And I'm just kind of thinking out loud here. So then the next integer, the third integer of the consecutive integers, we could add 2 to it. Does that make sense? So what we've done here is we've defined our 3 unknowns based on one of them, okay? So now we can go back to our problem, and it says the sum of these consecutive integers, which means we're going to add them up, is 72. So there's our first, there's our second, and now here's our third integer, and that total is 72. So now we have a 2-step equation, maybe 3. We're going to simplify, combine like terms, and solve. So when we combine like terms, we're left with 3x plus 3 equals 72. We're going to subtract 3 from both sides since we only have variables on one side. And we're left with 3x equals 69. We're going to divide both sides by 3. And we are left with x equals 23. Now that is only our first integer, so we have to make sure we're answering the question, which asks us what are the 3 integers, and they are 23, 24, and 25. Now you can go back and check your work by adding those 3 integers up and hope that they add up to 72. If they do, you know you've done the problem correctly. Here is our first distance, rate, and time problem. In this problem, the airplane left the airport flying at 180 miles per hour. A jet that flies at 330 miles per hour left an hour later. So the jet follows the same route as the airplane on parallel altitudes. So they're not going to run into each other. How many hours will it take the jet to catch up to the airplane? So the airplane gets a head start, right? And we know that we're going to let t be the time that the airplane travels. We don't know how long it travels yet, but we will eventually. Now think about if the jet, the faster airplane, or the faster plane left an hour later, we can take what we know about the airplane and we can subtract 1 hour from it to get the time the jet is in the air. Does it make sense? And remember, we were told that our airplane travels at 180 miles per hour. If you'll notice here, I have a distance, rate, and time table. And these students have found that setting up a table like this helps them think about the problem. So you want to imagine trying to get your work organized and keeping track of things. And so this table, a distance, rate, and time table, will help you do that. So I want to encourage you to make these tables as you're trying to solve these problems. Okay, so now ask yourself, what do we know about their distances? Well, in this case, we want to know when the airplane and the jet are at the same place, right? So their distances are going to be equal. They left from the same starting point, and where they meet up is going to be the same distance they've both traveled. So since we have this expression here, 180t, that represents the distance of our airplane. And then 330 times, notice the quantity, t minus 1, that represents the distance of our jet, the faster plane. And now we just have a few steps. We're going to use the distributive property to simplify the right side. And we're left with 330t minus 330. Don't forget to multiply that 330 by the -1 there. Frequent mistake by algebra students. Okay, and then we're going to combine like terms. I'm going to subtract 330t from both sides. I don't like to work with negatives, but in this case, it saves me a step. And so when I subtract, I'm left with negative 150t equals negative 330. Okay, I'm going to divide both sides by 150. And my time is going to equal 2.2 hours. So after 2.2 hours of the airplane traveling, the jet will catch up. So the question asks, how many hours will it take the jet to catch up, which is the faster plane? So the jet will catch up, and I want to encourage you to just write a sentence like, the jet will catch up after 1.2 hours of travel time, okay? So make sure you're answering the question as well. So the jet's only going to travel that 1.2 because we have to subtract the hour that the airplane had traveled. Okay, in our final example here, we have airplanes, again, jets, leaving, but they're traveling in opposite directions. Okay, so they're going in opposite directions here. So we want to be, this is a little different than that, but we can still set up a distance, rate, and time table. We just have to understand that their distances aren't going to be equal like they were in the last problem. So in this problem, two jets leave Dallas at the same time and flying in opposite directions. One is flying west, 50 miles per hour faster than the other one. After 2 hours, they are 2,500 miles apart. Find the speed of each jet, okay? So we're going to let x be the jet, the speed of the jet that's flying east, okay? Now remember, the jet that's flying west is going 50 miles per hour faster. So if we take the eastbound jet and add 50 miles per hour to its speed, we can get the speed of the westbound jet. So we're going to use that expression as x plus 50. Okay, now we know both planes, jets, are traveling for 2 hours because after 2 hours, they left at the same time, and after 2 hours, they are 2,500 miles apart. Okay, now remember, this expression 2x right here, right, represents the distance traveled by the eastbound plane. That's the distance of the eastbound plane. And then this 2 times the quantity, x plus 50, represents the distance that the westbound plane traveled. Now, what else do we know? We know their distances aren't equal, but we know together they have covered this 2,500 miles. So if we take our two expressions and add them together, what do you think that should equal? That should equal the 2,500 miles, okay? So now we have a multi-step equation. We want to make sure we're using the distributive property properly. and combining like terms and solving for x. Now remember what x equals. That's just the speed of the eastbound jet. So the question asks us to find the speed of both jets. Okay, so don't forget to leave that and answer that question. So as I simplify, I get 4x plus 100. I'm going to subtract 100 from both sides. And I'm left with 4x equals 2,400. And then if I divide both sides by 4, I get x equals 600. And remember, that represents miles per hour that the eastbound jet is traveling. So then the westbound jet is traveling at 650 miles per hour. And it's a little hour symbol there. And this is also miles per hour. Okay. Please don't stress if these distance, rate, and time problems aren't making sense. We're going to get a lot of practice in class. Don't forget to complete your post-video check, especially if anything that I did in these problems didn't make sense or left you wondering something.